right, here we go. So welcome to today's lesson about creating some things called orbital diagrams. And this is the key idea that we're working on today, because in class we talked about a variety of craziness about how the electron cloud was structured, and that there was a bunch of the basics, which is energy levels, that we knew that those were there, but then sublevels and orbitals were in there as well. And by the time we started to draw our simple little diagram of an atom that started off life looking like this, it ended up looking crazy like this, where we had the nucleus right here, and then the first energy level looked like that, and then the second energy level looked like that, and then the third energy level looked like that, 1, 2, 3, 4, 5, because it had S and P and D sublevels to it. There was a lot of craziness that's going on here. So this is an S and a P, sorry. And trying to figure out all of this stuff and trying to figure out a way to draw these sorts of atoms is very difficult. If you had to try to draw this kind of, I don't know, this crazy looking thing over here that looks like a record player every single time, oh my God, there's just no way to do it. We need a shorter method for being able to kind of represent all of this complexity in a much simpler way. And so this method that we're using is going to be something called orbital diagrams. Rather than drawing out these things that look like records, we're going to draw bunches of circles and arrows, basically, is what we're going to end up doing. And this will help us kind of have a shorter way to represent all of the electrons in an atom in a graphical kind of way. So here's some of the basic rules for how we draw orbital diagrams. There's a couple of basics that we need to kind of always keep. We'll start kind of building some examples from this. I'm just going to kind of lay these out here at first, and we'll practice using them here in just a second. So number one, rather than drawing our orbitals kind of like we were drawing them earlier like that, because that just gets, just too crazy to be able to do, we're going to do a little simpler method. We're going to use simple circles to represent an orbital. So that would be an s orbital, and we'd have a set of 3 would be a p orbital, because there's 3 sublevels for each p, or sorry, 3 p orbitals for each p sublevel. Inside of there, instead of drawing dots or something like that for electrons, we're going to use arrows. So something along these lines is what these diagrams kind of end up looking like. So we've got a variety of pieces of this. A circle is going to represent a sublevel, or a group of circles will represent the set of orbitals for a sublevel. And then we're going to draw little arrows on the inside to represent the number of electrons that we've got. A couple of other rules to keep in mind as we're dealing with this. When you are drawing a set of these circles, you have to draw the full set to it. You're not allowed to draw like an S and then a single P. So if this was the S and this was a P like that, you would actually have to finish drawing the full set. So as soon as you start drawing a P, because there's 3 orbitals in each P sublevel, you have to draw all 3 circles. It's okay, and you'll see this later on, to have some empty circles that maybe don't have any arrows in them. In fact, that's correct. So it's not correct to just draw a single circle for P, or maybe just 2 circles or something like that. You have to draw the full set. So if you start drawing P orbitals, you got to draw 3. You start drawing D orbitals, you got to draw all 5. So let's take a look at how this works for some simple elements. So we're going to start off with some basics here. You may want to have a periodic table sort of nearby you. A paper one's probably a good idea, so you can see how these work. What I've got written over here on the left is a couple of examples to use, the real simplest elements, and how we're going to draw the orbitals or the orbital diagrams for these things. So basically what we want to be able to do is draw circles for our energy levels and sublevels, and even for each orbital, and then we're going to use arrows to represent each of the electrons. So in here we're going to have to draw 1 arrow, total of 2 arrows, lithium's got a total of 3 arrows, and beryllium's got a total of 4 arrows, or electrons that we're going to need to deal with. So I'm going to start off by drawing some circles. So for hydrogen, hydrogen's got 1 electron. It's up in that first energy level, so I really only need to draw 1 circle for it. It's that first energy level, the S sublevel, and there's only 1 orbital within an S sublevel, so 1 circle. And when I want to represent the electron for it, all I need to do is draw a single arrow. Typically you can draw it as an arrow up or an arrow down. My arrows I know are going to look kind of funny just the way I've drawn them, but when you draw a lot of arrows you tend to draw them like this, kind of half arrows. And so that's how I would draw an orbital diagram for hydrogen. So let's take a look at helium. Helium's very similar. Helium only has 2 electrons to deal with because it's atomic number 2. So when we're going to draw our start off, it's in the first energy level. So there's my 1s. And then the question becomes, how do I draw these 2 electrons? Well, This is one electron, and I'll point an arrow upwards, and a second electron, I'll point the arrow downwards. In class, we talked about bunk beds, top bunk, bottom bunk, and that's kind of what we're going to draw here, an up arrow and a down arrow. And again, by convention, it's up and down, not left and right, or something else along those lines. And yes, you do need to draw them as arrows. You are not allowed to draw them this way, where you just draw the circle for it, and then go line, line. That's not acceptable. I will mark it wrong. So make sure you put some sort of an arrowhead, even if it's just a half of an arrowhead on there, to make it correct. Okay, lithium has 3 electrons total that we have to deal with. So I start off by drawing my first energy level, which has an S sublevel to it. So there's one circle for it. And I'm going to draw my electrons in there. There's first electron, and then there's a second electron. And I have to stop here for a second because there can't fit any more than 2 arrows in any one circle. In other words, you can't have more than 2 electrons in one orbital. So I've got those 2 drawn, which is fine, but I'm going to need to draw another circle. So the second circle I'm going to draw is going to be, if I can get my pen working here, I'm going to draw a second circle next to it. Now this is the second energy level I'm starting off. And if you remember, the second energy level starts off also with an S sublevel. So I can put my third electron right there, and there it is. And this is now complete. I don't have to draw all the P's yet, although if you were to draw the P's over on the side like that, 2p, because you're thinking, oh, second energy level, all those are in there. That's totally fine. I will not mark that wrong. In fact, that's perfectly correct. You don't have to draw necessarily every single circle, but you just have to draw a set of circles. Okay, beryllium. Beryllium's got 4 electrons. See if you can figure out how to draw this one out. So, beryllium has a total of 4 electrons. So some of them are going to start off in the 1s, the first energy level, and in the S sublevel. So I'm going to have 1 and 2 electrons there. I don't have all my electrons taken care of yet. I need a total of 4. So I have to draw my 2s energy level as well. And then these guys are going to have, there's my third electron, and there's my fourth electron. So these now, as I've drawn them on the board here, or on the screen here, are complete orbital diagrams for these very simple elements. So this is hydrogen, this is what helium is, this is what lithium is, and this is what beryllium is. So take a note that I've drawn circles for each one. I've got arrows inside the circles, either 1 or 2. It's okay to have 1 in there, it's fine. And then I've got each one of the circles labeled with the energy level and the sublevel that goes along with it. So let's take a look at what happens as we move over to the bigger elements. Okay, so here we are. We're still in the same row. We're going to look at a couple other ones here from that second row. I'm not going to do all of these because, it's just going to take too long. So I'm going to choose a couple of examples. We're going to do carbon, oxygen, and neon. So you may want to grab that periodic table and find them. I've written down the numbers of electrons here for you so you don't have to look them up if you don't have your periodic table. But this is where we're going to have to start kind of doing a little bit more in terms of writing these orbital diagrams out. So carbon's got, well, it's got a 1s energy level. And I know for sure it's going to have a 2s energy level. So I'm going to start drawing these guys out. So there's a first electron, second electron, there's the third, there's the fourth, but I need 6. So that means I have to start drawing p orbitals, or p sublevels. And remember, if I start to draw the p sublevel, I have to draw all 3 orbitals to it. You're not allowed to draw just one circle, even if you don't use them. So I can put in my last electrons. I've got 4 already taken care of, right? I have, let's see, 1, 2, 3, and 4. So I need 2 more to get to a total of 6. So here's number 5. And then the last one's going to go in an empty circle. You're not going to pair it up. It's going to be over here by itself. I joke about the roommate example that if you've got 2 people living in a 3-bedroom apartment, you wouldn't have 2 of them sharing the same bedroom. You have them in separate bedrooms like that. So make sure to spread them out and use separate individual circles before you start pairing them up. So this is the full electron configuration for carbon. Oxygen's is actually quite similar. So it's in that same kind of row. I know I'm going to have to do the 1s. I'm going to have to do the 2s. So I've got 1, 2, 3, 4. Now I need to get a total of 8, so I have to get into the P's here somehow. So I'm going to start drawing those guys out. There's my 2p sublevel with its 3 orbitals to it. So I've got a total of 8 electrons. I've got 4 already drawn, so here's number 5, here's number 6, here's number 7. And now the 8th electron, by convention we show it paired up in that first one. It could be in any of them, but sort of just by a simple pattern, we generally tend to do it in that first circle there. So now we have a total of 8 electrons. There's 2, there's 4, there's 6, there's 7, and 8. So we would say that oxygen has 2 unpaired electrons. Up above, carbon also has 2 unpaired electrons, so it's something that kind of makes a difference in terms of bonding later on. So I just wanted to point out that this idea of having some of them that are paired and then some of them that are open kind of makes a difference. Okay, your turn. See if you can fill out neon for me in terms of its orbital diagram. And neon has a total of 10 electrons. So now you hit pause. I'm going to keep going, but hit pause and see if you can do it. All right, here we go. Neon's going to have a 1s. It's going to have a 2s. You probably figured out it's going to need the 2 p's. 1, 2, 3, like that. There's my 2 p's. And neon has a total of 10 electrons. So there's 1 and 2. There's 3 and 4. There's 5, 6, and 7. Notice how I drew those separate first. And then there's number 8. There's number 9. And then there's number 10. And neon is full. Its 2p sublevel is full of electrons. This is one of the reasons why neon is a noble gas, because it actually doesn't have any more electron space available in its second energy level. All right, let's go see what happens in the third energy level. So here we go. We got the third row elements. These get a little bit wider because we have more electrons we have to deal with, so more circles. And we're going to take a look at how these guys work out. So for sodium, I've got 11 electrons that I have to take care of to try to figure out how to make these guys go. By the way, I can start to guess how many circles I need because there's 2 electrons per circle. And if I've got 11 electrons, that means I'm going to need at least 5 or 6 circles. So it kind of gives you an idea of how many orbitals you're going to have to draw. And it kind of can give you a little bit of a hint of how many circles you're going to have to need to go make room for it. So anyway, for sodium, I'm going to start drawing my stuff the same way. I know I'm going to need a 1s. I know I'm going to need a 2s. Definitely going to need those 2 p's as well. There they are, 2 p's. And let's see how much room we've got here. So we've got 11 electrons that we have to draw. So here's 1, here's 2, there's 3, there's 4, 5, 6, 7, and then 8, 9, and 10. So I need 1 more electron. So it's going to have to move out of the second energy level, because the second energy level is already full, excuse me, up into the third energy level. And the next thing that fills, remember, each energy level starts off with an S sublevel. So I can draw my 1 circle for my S sublevel, and there is my last 11th electron. So this is just how we get into that third energy level. You start using those S and P's again. You're just sort of wrapping it around. So take a look, see if you can kind of start to figure out aluminum and chlorine, and I'll kind of do these here behind you. So now's a really good time to hit practice or hit pause, see if you can do them out real quick, and then I will draw them as well. So here we go, aluminum. 13 electrons. Wow. Okay, 1, 2, 3. So I know I'm going to need my 1s. I'm going to need my 2s. I'm going to need my little 2 p's here. Probably going to need my 3s. So let's see what we got. All right. 13 electrons. So there's 1 and 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, and 12. Well, crap, I need 13. So what do I do with that? Well, the 3s wasn't enough. So that means now the next set of sublevels has to fill up, and that's going to be the 3p. Now, if you've got room, unlike me, you would normally do this in the same line, but because I'm kind of at the end, I'm going to wrap mine around and drum underneath it, but you can do this as a single row. When I do chlorine down here, I'll be a little bit smarter about it, give myself some more room. So I would draw my set of, like this, 3p's, like that. And again, you have to draw all 3 of them because they are p sublevels. And again, how many electrons do I have? Well, I've already got taken care of 2, 4, 6, 8, 10, 12. So that means I just need room for 1 more lonely electron all the way down there in its p sublevel all by itself. And yeah, that's totally fine. Again, remember that you have to draw the full set of all 3 orbitals, and it's fine if you've got empty ones to it. It would not be okay to just draw a single circle like that. So make sure you draw the full set. As soon as you draw a 3p, you have to draw 3 of them. Any sort of P, you draw a 3p form. All right, chlorine, your turn. Chlorine's got 17 electrons, so now you get the idea that these are going to get really, really wide to be able to draw enough room for all of these. Again, I've got 17 electrons, so if I divide that by 2, right, it's like 9 or so circles that I'm going to have to draw at least to be able to make this thing work. So it gives you an idea of how wide your circles are going to be. All right, so let's go. Here it is. I'm going to draw my 1s. I'm going to draw my 2s. I'm going to draw my 2 p's, 1, 2, 3. Well, those are ugly, but it still works. 2 p's. I'm going to draw my 3s, 3s, and then I'm going to draw my 3 p's, 1, 2, 3, like that. And there's my set of 3 p's. So that's how I would normally do it if I had a wide enough piece of paper. And I need 17 electrons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and then 13, 14, 15. And I double them up, 16 and 17. And we can see from this that chlorine in its last energy level, last sublevel, it's got one unpaired electron to it. Again, it becomes an important thing when we start to figure out ion charges and stuff like that. So it's kind of good to be aware of how many paired and how many unpaired are there. Okay, about to get to the hard stuff. Here we go. So far, so good. It's been pretty easy in terms of figuring out what the energy levels and sublevels are in the orbitals. Every time you have an energy level, you add a sublevel to it. So the first energy level has just an S. The second energy level has an S and a P. And the third energy level has an S, a P, and a D. So it has 3 sublevels to it. Unfortunately, and this gets a little bit tricky for us, they don't fill quite in the order that we would predict they would. So this diagram that you're looking up here is kind of a different way of representing what the energy levels are. So you can see here's your 1s down here. They show it down low because like this would be where the nucleus would be, closest to the nucleus. Highest energy is up at the top, furthest away from the nucleus. So there's our 1s energy level. And then there's our 2s followed by our 2p. There's the 3 orbitals in that p sublevel. And then the 3s comes up along with the 3 P's, and again we've got 3 sublevels for this. And then this is where things start to get a little bit weird. It turns out that there's something called energy level overlap, where the 3D, which you'd think would be next, S, P, and then D, is actually just a touch higher energy level than the 4S. The 4S kind of sneaks in underneath. Yeah, it's up another flight of stairs, it's up another energy level, but it's a much smaller apartment. So it just happens to be a little bit of overlap, that after the 3P fills up, sneakity sneak, the 4S fills in. And after the 4S fills in, then the 3D goes back and fills up. I know that's kind of a weird thing, it doesn't make a lot of sense, it's just the way the world works. Here's the good news. Oh, by the way, here you can see there's another set of overlap kind of up in this region. The same exact thing happens in the 4th energy level, that the 4S, then the 3D, then you get the 4P, and then the 5S, which makes sense, but then you get this overlap with the 4D. So this happens in a couple of different spots in here. So I'm sure you're wondering like, oh my gosh, how am I going to remember this? Well, here's the good news. There's this cool diagram, this thing down here, la-la. It's called the arrow diagram, A-R-O-W diagram, because it's got aerogram, oops, if I could spell, I-A-G-R-A-M, that thing right there. The good news is I'll give this to you on the test. Yay, you don't have to try to memorize this kind of thing down here. This big diagram up here, I just wanted you to see what it looks like, but you don't have to necessarily do that because this little diagram over here shows the same information. If you learn to follow the pattern of arrows on here, the arrows will tell you what fills up. So you kind of follow the arrows down. When you get to the bottom of an arrow, you go to the top of the next one, go down, top of the next one, go down, top of the next one, go down. So this tells you the order that all of these crazy things start to fill in, and it takes care of the overlap, so you don't have to memorize it. So the first thing that fills up is the 1S. The second thing that fills up is the 2S. The third thing that fills up is the 2P, and then the 3S, and this makes sense so far. And then we get to the 3P fills up, followed by the 4S. You got to follow the arrow down. And this is where that weird arrow overlap starts to happen, where it's 3P, then 4S, and then the 3D goes and backfills, followed by the 4P, 5S, 4D, 5P, 6S. It gets really crazy down in this region down here when we get to big elements. The good news is for you, typically we stop kind of after we get into about the 4P, 5S kind of region. So there's a little bit of overlap, but these ones down in here, we're starting to get into F orbitals. That's kind of extra credit territory. So let's take a look at applying this arrow diagram to a couple of examples. So here it is, our arrow diagram is located up here in the corner so that you don't have to try to find it someplace. And again, I'm giving you one in class so you don't have to try to memorize this. But let's take a look at a couple of these 4th row examples. We've got calcium, iron, and germanium. We've got a whole bunch of electrons here that we have to start dealing with. Lots of circles. So I'm going to try to draw small so that you can see this. And hopefully this will work out well. So we've got 20 electrons for calcium, so we're going to need at least 10 circles to be able to make this thing work. So I'm going to start up on the top row and kind of make a second row probably by the time I do this. So here is the 1S, here is the 2S, and here is the 2P. I'll draw them like that, 1S, 2S, and then here's my set of 2Ps. So let's get these guys taken. 1, 2, weird, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ugh, okay, so there's 10. 10 to go. So what fills up after the 2P? I'm going to look over here at my arrow diagram just to kind of demonstrate how to use this. I've got my 2P filled up, so the next thing that fills up, trace the arrow down, is going to be the 3S. And after the 3S, I go to the top of the next arrow, is the 3P. So nothing too weird yet. So let's go 3s, sorry, and then 3p like that. So there's my 3s, and there's my group 3p's. Okay, so how many electrons do we have now? As I have it drawn already, this up here, 2, 4, 6, 8, 10 electrons. I need to get to 20. So here's 11 and 12, 13, 14, 15, 16, 17, 18, and then where does number 19 and 20 go? So I'm going to go check back with my arrow diagram. I just drew the 3p's, so I follow it down. The next thing that fills up as predicted is the 4s. So this one isn't too crazy at all. So I can just draw my 4s. Remember, only one circle required for the 4s. And there's my 19th and 20th electrons filled in. So that one's pretty straightforward. Iron's going to be a pain in the butt, though. All right, let's take a look at 26 electrons. That means I need at least 13 circles. So to save myself some time, I'm going to start drawing most of this, because I know that this part's going to have to be exactly the same, because this one had 20 electrons. I'm going to have to at least get to this, and then we'll start to figure out what goes on after this. So let me start drawing my circles. There's my 1s, there's my 2s, there's my 2p, 2p's like that. Here's my 3s, here's my 3p's, 3s, here's my 3p's. I know I need my 4s like that. All right. So I'm going to fill them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there we've got that part done. Now let's go check back at our arrow diagram. We've got the 4s filled in. So we're up at this arrow diagram up here is the one we just filled in. So now take a look what fills up after the 4s. Go to the end of this arrow. You go to the top of the next arrow, which is here. And the top of the next arrow says the 3D is what fills in afterwards. So if I want to start drawing 3D sublevels, that means I have to draw 5 orbitals. This is the first time we've had to do this. Just like the P has 3 orbitals, 3 circles, the D always has 5 orbitals and 5 circles to it. So I'm going to draw mine on my next line just so I have enough room. So this is going to be the 3D, so let's see, D, 1, 2, 3, 4, 5 circles. It's a big long set. Kind of a bummer right now, but that's what it is. All right, how many electrons do we need? Remember, this was 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons that we've already drawn up in here. That means I need to draw 6 more electrons in my d orbitals. So here's number 21, 22, 23, 24, 25, and then there's 26. So that means that our friend iron here, in its last sublevel, has 4 unpaired electrons, 2 paired, and then 4 unpaired electrons. Okay, your turn. See if you can do germanium, which is Ge with 32 electrons. Gosh, you're going to need at least, what is that, 16 circles to draw. So this one gets a little bit tricky. And I said I'm going to do it after you here, but this is going to take a lot of room to draw this many circles. I don't make you do this many orbital diagrams, by the way, so you don't have to do too many of them. All right, germanium. I'm going to draw all the stuff that I've got up above because I know I'm going to need it. 1s. 2s, there's my 2p's, 2p's, there's those guys, there's my 3s, my 3p's, there's 3p's, wow, my writing's getting worse, there we go, and here's my 4s, here's my 3d's, because I know those guys are going to come next, 1, 2, 3, 4, 5, there's my 3d's, like that. That's kind of my full set, sorry I didn't have a spot to label them underneath. So how many electrons do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so my 3D is full, and I've got 30 electrons that are drawn. I have to get 2 more in there, so that means I'm going to have to draw some more stuff. So let's go back to our arrow diagram. Okay, we're back up here in the arrow diagram. We just filled up, what was it, the 3Ds. Oh my gosh, all of those are now full. So what fills up after the 3D, follow the arrow down, is the 4P comes next. So the 4P is what I draw next, and this is going to be 1, 2, 3. Those guys right there are the 4Ps, and they fill up after the 3Ds. It's kind of weird, I know, but that's that orbital overlap, that weird stuff that we see. So if I remember correctly, I had 30 electrons already taken care of, so there is number 31 and there is number 32. Pretty incredible in terms of how long these are, but this tells us again a lot about what's going on here, that we've got, this is our last sublevel that's being filled. It's the 4p. I've got 2 unpaired electrons and 1 empty orbital in there in that 4p. My 3d was completely filled up, and this is over in that next block. Okay, so there you go. You've taken a look now at practicing drawing some orbital diagrams for a variety of pretty challenging elements. If you want to kind of figure out how to start drawing D's and F's and crazy stuff, you can do this for any pattern. You just have to have a lot of room for a lot of circles and a lot of arrows. So hope that cleared up some examples for you, and I'll see you in class for some practice.